All right, this is section 5-7, inequalities in two triangles. So let's start off with vocabulary. We're going to circle the included angles in each diagram. So in this diagram here, B is included between these two sides and E is included. In number 2, X is included and Z is included. All right, exercise 3 to 5. Cross out the values that do not satisfy the comparison property of inequality. All right, this does not satisfy, this does not satisfy, and this does not satisfy. So write a number in each group that does satisfy. So in order for this to work, A equals 2, and this one, B equals 8, and in this one, B equals 1. Okay. So hinge theorem. A hinge is a device on which something else depends or turns. To hinge upon means to depend on. So everything hinges on a decision is a verb. The hinge on a gate allows it to swing open or closed. That's a noun. Your plan hinges on your teacher's approval is a verb. And the lid was attached to the jewelry box with 2 hinges. That's a noun. Okay. So theorems 513 and 514, the hinge theorem is converse. So it states basically, if 2 sides of one triangle are congruent to 2 sides of another triangle, the included angles are not congruent. The third sides are not congruent. So the third longer side is opposite the larger included angle, and the larger included angle is opposite the larger third side. So using symbols in 513, measure of angle A is greater than measure of angle C, therefore BC must be greater than YZ. The converse, if I know BC is greater than YZ, then measure of angle A has to be greater than measure of angle X. Okay. So why are these like SAS and SSS? So 5-13 compares 2 pairs of sides and the pair of included angles. So that's just like SAS. 5-14 compares 3 pairs of sides. So that's just like SSS. All right, let's use a problem here using the hinge theorem. So what inequality relates LN and OQ in the figure at the right? Using information and diagram to complete. So the included angle in triangle LMN is angle M. The included angle in triangle OPQ is angle P. So circle the side opposite the included angle in triangle LMN, and that would be segment LN. Underline the segment side opposite the included angle in triangle OPQ, and that would be QO. So using the hinge theorem to complete the statement, the measure of angle M is greater than the measure of angle P, so we know LN is greater than OQ. All right. So from the diagram, you know that the triangles have 2 pairs of congruent corresponding sides. LM is less than OP, and that measure of angle N is equal to 90. So let's use this. Measure of angle LK is less than the measure of angle N. By substitution, 3x plus 18 is less than 90. Subtract 18 from both sides, so 3x is less than 72. Divide by 3, so x is less than 24. Okay. Measure of angle K is greater than 0. So 3x plus 18 is greater than 0. So 3x is greater than negative 18 when I subtract 18 from both sides. Divide by 3, and I get x is greater than negative 6. So putting these together, negative 6 is less than x, which is less than 24. All right, let's write a proof. We are given MON is equal to 80, and O is the midpoint of LN. So I like to mark this up. Here is the midpoint, and MON is equal to 80. Okay. So this was given. I know that MON plus MOL is equal to 180. That is by supplementary angles or linear pair. So substitution. Now I'm going to subtract 80 from both sides. Since O is the midpoint, I know it creates two equal segments, so O is the midpoint. And I now have the reflexive property. Okay. Now I know 100 is greater than 80, so therefore a measure of MOL must be greater than a measure of MON. So by the hinge theorem, the segments must be in that relationship. All right. So write the inequality relating FD and BC. Okay. So circle the correct statement. AC is equal to EF. AB is equal or congruent to ED. And measure of angle BAC is less than measure of angle FED. So by the hinge theorem, I can relate FD and BC. Write the inequality. FD must be greater than BC. All right, what happened wrong here? All right, which is true and which is false? Is AB equal to CD? That's true. AD equal to CB? That's false. BD equal to BD? That's true. So my friend should have compared AD and CB. The longer of the two sides your friend should compare is AD. So AD should be greater than CB. So we're going to conclude that the measure of angle ABD is greater than the measure of angle CDB. And that's the end of that section.